board. All right, all right. So if we work in something known as a conservative field, a conservative field is a field where if you do work in that field, you'll get all of your work back. So if you do some initial work, okay, you'll get all of your work back. So when we have this kind of scenario, we'll end up with our work energy theorem. Going to the conservation of energy law. So if you see this equation at the top right here, this side is going to do what? If the initial work is equal to the final work, what's going to happen to the left-hand side? Say that again. It's got to move over. Go for it. The question is, if you have work initial equals to work final, what happens to the left-hand side? Yeah. Say that again. You say 0, 0?
Yeah, it's sort of like.
Yeah, it's just going to be, that's one answer. Let me see. Sid, what do you think? Sid is there.
I think it zeroes out.
Okay. So what do you think, Dimitri? What do you think? If work initial is equal to work final, what happens to this side? It decreases. Okay. Yes. Well, if it's equivalent, you definitely, it's going to be, it just basically states this. It implies that work final minus work initial equals a 0. Okay, it's like if work initial is 2 and work final is equal to work initial, that means both of them are 2. So 2 minus 2 is 0. So we end up with 0 equals to 1/2 mv final squared minus 1/2 mv initial squared plus mgy final minus mgy initial plus q times this v final, this potential, is q times v initial. So what we'll do now is we'll take all of our initial events, kinetic energy initial in the initial case, potential energy, gravitational potential energy in the initial case, electric potential energy in the initial case, and now we'll move all of that to the left-hand side. When we move it to the left-hand side, we change what with these signs? How do we move it to the left-hand side? You have to, in this particular case, if I subtract this from this side, then that means that I'm going to end up with like twice this. So I have to add it to both sides in order to get rid of it. Y'all remember that from algebra? Yeah, here's the equal sign right here. Yeah, the addition principle of equality. If I, in order for me to get rid of this on this side, I have to add this to this side. This plus this is 0, but if I do it on this side, I have to do it on the left-hand side, which is the left-hand side of the equality. Cool? Because that's like, it's like a scale. It's like balance. So if I have something on this side, if I have a quarter pound of beef on this side, and I have some measures on this side, and I remove part of that quarter pound, then I have to remove part of this in order to keep the scale balanced. You could say equal it out, balance it, all of those things. Thank you so much, sir. Happy New Year.